Welcome back to Dr. OJ tutorial class. In this video, we shall discuss derivative of logarithmic functions. Stay blessed as you watch, and don't forget to click on the notification bell so that each time I upload a new video, you'll be daily notified. Thank you. Now, we have y is equal to log x base a, where a is positive and a is not equal to 1. Because if a is equal to 1, obviously it's going to give us a trivial solution. So, but our a is not going to be 1 this time around. Okay. Now we can start this with differentiation from the first principle. If you could recollect vividly, when you are differentiating from the first principle, you are expected to have an increment of y with respect to that of x. So add y to the increment of y. You have y plus the change in y equals to log x plus change in x base a. Okay, so if you make change in y into a formula here, you have change in y equals to log x plus change in x base a minus y. Okay, that will give us change in y equals to log x plus change in x base a minus our y here as given is log x base a. So this one can be written as now log changing y equals to the log base is common, so we can say log base a x plus change in x all over x. This is from our knowledge of logarithm that we have learned previously. Now we can divide both sides by change in x. So we have change in y all over change in x is equal to the whole of this can be log x plus change in x all over x base a all over change in x. So this one can be written as 1 over change in x log x plus change in x all over x base a. Okay? Are we following? Now we can rewrite this as 1 over x multiplied by x all over change in x log x plus change in x all over x base a. Okay? Yes, so as to be able to get an expression that can be common. We are trying to look for expression that will give us a common variable. So changing y all over changing x now is equal to, we have rewritten this 1 over changing x is the same thing as this if you look at it. So it's the same thing. So we can have we can also have this as 1 over x times x over changing x, log this one will be what? Base a of 1 plus changing x over x. Yes. Now I think you understand that. That is, if you divide this and this by x, x is a divisor for both. X over x is 1, then plus, can split that. Okay? I've not done anything funny here. So this one could be what? It could be said to be. Now, we can have this one as 1 over x log, of 1 plus changing x over x, bringing this one as x over changing x base a. Remember, in the logarithm in the theory of logarithm, if you have say log, let's say 3 log x base a, it can be what? Written as what? Log x raised power 3 base a. I hope you can remember that. Very good. That's what I did there. So this one can be the same thing as written as 1 over x log of base a of 1 plus 1 all over changing x over x, x all over changing x. Yes. The reciprocal of this will give me this. I want to get an expression, in such a way that I'll have a common value here. So if I divide this by the whole of this by this, I will get this. That is what I've just done there. I've not done anything, funny there. I've not done anything funny. Or better still, this one could be x all over changing x. Yes, that is it. So this one, sorry about that. Changing x over x is equivalent to this. Yes. Yes. If you find the reciprocal of this, you get this. So I've replaced this now by this. Or let's check. Let's check what I meant there. It's not difficult at all. What I meant there is I want to replace this change in x over x in such a way that it will give me this form of expression. So, and I said, if I divide the inverse of this, I'll get this. Let's say 1 over 1 divided by x over change in x. That will give me 1 over 1 times change in x over x. That's it. So, change in x over x is 1 over x over this. Okay. So, which means that I've gotten a common variable, which was my initial target. I've gotten a common variable, which was my initial target. So, I have what? Change in y all over change in x now is 1 all over x log of base a of 1 plus, I'm trying to rewrite this. Okay. So since that is common, let's p equals to x all over change in x such that change in x tends to 0 as p tends to infinity. Then we have change in y over change in x is equal to 1 all over x log of base a into 1 plus 1 all over p raised per p. Yes. So the y dx now will be limit as change in x tends to 0, of change in y all over change in x, which is the same thing as limit as p tends to 0 over 1 all over x log base a of 1 plus 1 all over p raised per p. Okay. So with that, we have this is equal to 1 all over x. The whole of this is e. The whole of this, when you take p to be tending to 0, the whole of this value will where now we have e is equal to limit as p tends to 0 over 1 plus 1 all over p raised per p. Okay, that is how we got that. So in that case now, the y dx is equal to 1 all over x log e base a. So that is that about that. Now let's look at examples so as to buttress our assertion. Let's look at examples so as to buttress our statements. Let's look at examples. Now the very first example, find the derivative of example 1. Find the derivative of log 3x plus 2 base a. Now, how do we go about this? Fine. Let's u be equals to 3x plus 2. Okay. Now, du dx will be free. I hope you know that. Fine. So, we now have y is equal to log u base a. Don't forget, find the derivative of this means you are finding the derivative of y equals to this. I hope you understand. So anytime you come across a question like this, it means y is the independent variable. Is the dependent variable. So y equals to this value. Okay. Now, how do we now get this? The y, the u now will be, 1 all over u log e base a. I hope you can remember that very well. 1 over u log e base a. Okay. Therefore, the y dx will be the u dx times the y du. Which will be your du dx is 3 times your dy du is 1 all over u log e base a. So this one will give us what? 3 all over u log e base a. And that will give us what? That will be dy dx will be 3 all over, what is our u? 3x plus 2, then log e base a. So the problem is solved. The problem is solved. I hope you understood that. Okay, let's solve one more example. Maybe with this you understand more. Let's solve one more example. Let's solve one more example. Okay. Now example, given that y equals to log x base a. So here we know that ordinarily we want to find want to evaluate this. This one will be let u equals to x. So you know the u dx is equals to 1. And now say that that implies y is equals to log u base a. So which eventually will mean the y, the u will be equals to 1 all over u. I hope you understand. 1 all over u log e base a, which we have earlier done. Okay. Now, and you know our u is x, which will be what? 1 all over x log e base a. So if our a is equals to e, then if a is equals to e, then what happens? So we now have dy dx will be 1 all over x log e base e. So that would be what? 1 all over x. That is if a is equals to e. So now have y is equals to log, y is equals to log x base e from here now. If our e now becomes this, so the y dx will be equals to 1 all over x. That is if that happens, and which is same thing. This one is same thing as ln x. Ln x. So it means that if you have y is equals to ln x, or if y is equals to ln x, the y, the x is equals to 1 over x. Or if you come across question that say y is equals to log x base e, the y dx is still 1 over x. So let's look at another example there. Let's look at another example there. Let's look at another example there. Suppose we have let's y example, differentiate y is equals to ln f of x. Fine. So it's very simple. What you all need to do was let u be equals to f of x. So differentiating u with respect to x, you have du dx is equals to f prime of x. Okay. And so y now becomes what? Y will now become ln, because your u will now replace f of x, ln u. So the y, the u will be 1 over u from here. When y is equals to ln x, the y dx was 1 over x. So when y is now equals to ln u, the y dx, the y du will be 1 over u. Very straightforward. Okay. And and you know that since the y dx is equals to the u dx times the y du. Okay, I hope you know that. Yes. So that means the u dx is f prime of x, then multiplied by the y du is 1 over u. So what would that be? What would that be? So that would now be therefore the y dx will be f prime of x all over u. or you can say 1 over u f prime of x, which is 1 over, what was your u? F of x, f prime of x. You can write as f prime of x all over f of x. So that solves the problem. So with this, we have come to the end of differentiation of logarithmic functions. Do well to click on the notification bell so that each time I upload a video, you'll be duly informed. Stay blessed.